So you've got this AI that can do a little bit of everything, a real jack of all trades. But how do you teach it to be a master of just one thing? Well, as we're about to see, the process has a really interesting twist.
I mean, really think about that for a second. These AIs are amazing, right? They know a little about everything. But what if you need one to do something perfectly? Not just kind of well, but perfectly, every single time. How do you channel all that general knowledge into one super specific skill?
So let's talk about a model's new mission, going from a generalist to a specialist. Yeah, this is basically the story of a model's training day. We're going to watch a generalist AI get a very, very specific job to do.
And this difference is so important. Your general purpose AI is incredible. It can write you a poem, then debug your code, maybe even suggest a recipe for dinner. But sometimes you don't need a poet or a coder. You need a specialist, an expert who follows one very specific rule without fail every single time. All right, next up, gearing up for training. We've got to assemble the AI's toolkit. So how do we even start this? Well, first things first, we need the right tools for the job. It's kind of like getting a student ready for a super specialized advanced class. Okay, our setup has 4 main parts. We've got our trainee, the model itself. Then there's the textbook it's going to learn from. We've also got a pretty cool efficiency hack to speed things up. And finally, the training program. The secret sauce, really. Every single one of these pieces is absolutely critical for what's about to happen. So our trainee is a pretty small model, just 135 million parameters. But don't let this size fool you. It's very capable. You can think of it like a nimble, eager student. The great thing about using a smaller model is that it learns fast, and you don't need some giant, expensive supercomputer to train it. Okay, what else is in the toolkit? Well, for a textbook, we're using a dataset of short stories. To make things efficient, we're using a clever trick called LoRA. The best way to think about LoRA is, instead of rewriting an entire textbook, you're just adding a few super smart sticky notes in the margins. It saves a ton of time and memory. And then, the grand finale, the training program itself, which is called GRPO. That's our special coaching method, and it's really what this is all about. Okay, so now we're defining the winning move. This is all about the power of the reward function. I mean, this is the most important question, right? How does the model even know if it's doing a good job? Well, that brings us to the single most important tool in this whole process.
Is something called a reward function. And honestly, you can just think of it as the one rule to rule them all. It is the North Star for the AI. It guides every single thing it does during training.
So what's the mission? What's the rule? It's super simple, but also incredibly strict. The model has to generate text that is exactly 50 tokens long. And tokens are basically the words or parts of words that AIs think in. So yeah, not 49, not 51. It has to be precisely 50. That is its one and only job. And now it's time for the training montage. We're putting the model to the test. With that mission locked in, the training kicks off. The model just starts practicing again and again and again with the GRPO trainer and that reward function guiding its every move. And you know what's wild? This whole transformation, turning a generalist into a super focused specialist, it's not some epic weeks-long process. Nope. On a single, pretty standard GPU, we're talking about roughly 1 hour. That's it. An hour. Okay, training's over. Now we've got to decode the scorecard. This part is all about when losing means winning. Yeah, you heard that right. After the hour is up, we check the results, and this is where things get, well, really weird and kind of backward.
So we're looking at 2 main numbers on this scorecard. The first one is the reward. You can see it's heading towards 0. Now in this setup, 0 is actually a perfect score. It means the model is nailing that 50 token target. So that's awesome. But then we look at the other number, the loss, and it's going up a lot.
Okay, wait a minute. For anybody who's spent any time with machine learning, you know that a rising loss is a massive red flag. Like alarm bells should be going off. It almost always means your training is failing, badly. So what in the world is going on? And this right here is the big twist. In GRPO, a rising loss is exactly what you want to see. It's not a bug, it's a feature. It's not just okay, it's actually the #1 sign that everything is working perfectly. This is just a brilliant way to understand what's happening. The loss here is basically a measure of how different the model is becoming from its original self.
That number is going up because the model is successfully ditching its old generalist habits. It's literally unlearning how to be flexible so it can become a specialist who follows one rule. That growing difference? That's the whole point.
Mission accomplished. The specialist emerges. So, after that totally weird but apparently successful training session, what's the final verdict? Did our little model graduate? Did it learn its new trick?
Oh yeah, it absolutely did. The newly fine-tuned model now spits out text that is exactly 50 tokens long, every time. It follows its new rule to the letter. Mission accomplished. Our trainee is officially a specialist. So, what are the big takeaways from all this? First, fine-tuning is how you turn a generalist AI into a specialist. Second, that reward function is everything. It gives the AI its goal. Third, GRPO is a really powerful and efficient way to teach an AI a new rule. And maybe the coolest part? Sometimes the results that look wrong, like a rising loss, are actually telling you that you've succeeded.
And all of this leaves us with one last big question to think about. If we can teach an AI to follow pretty much any rule this precisely, the question isn't how we do it anymore. The real question is, what should we teach it to do next?